Hello students, I am Dr. Sanjeev Ponia. We are discussing 3D concepts and object representation. As I told you that in the real world we are dealing with 3D objects, but it's not possible to represent that 3D object on a view plane. So this is the reason that we have to apply some procedure to convert that 3D object into 2D image so that it can be displayed on any image plane. So over here we will discuss 3D concept and object representation in this. During this lecture, we will discuss about polygon surfaces. As in last lecture, we discussed 3D display method. Over here, we will concern about polygon surfaces. We will see here that how we can represent a polygon using polygon tables, using plane equations and polygon meshes. In other lectures, we will discuss about plane equations, spline representation, cubic spline interpolation method, Bezier curves and B-spline curve and surfaces. So today lecture is for polygon surfaces. So as I told you that polygon surfaces can be represented in three ways, that is polygon tables, plane equations and polygon meshes. This is a surface that can be thought of as a surface composed of polynomial faces, means there are a lot of faces you can see over here in this object. This is one face, this is second face, this is third face, this is fourth face, this is another face, and this is another face. So this object is composed of different polygon faces. The most commonly used boundary representation for a 3D object is a set of polygon surfaces that enclose the object interior. So this is the most way in which the most of the objects are going to be represented using this. So polygon surfaces are represented in computers by different methods, as I told you. Number one, polygon table, plane equations, then polygon meshes. Here we will discuss about these three in detail, and we will see that why the another one is going to prefer on first one. So we will see that betterment of different methods. So first we will start with polygon tables. As the name represents, this is the table. Those are related to polygon, means those stores the characteristics or details of a polygon. As we say that a data table means a table that contains some data. So representation of vertex, coordinates, edges and other properties of polygon into table form is called polygon table. When we are going to represent all the information about the polygon in table form. Polygon data tables can be categorized into two groups. One is geometric table and second is attribute table. In geometric table, the coordinates etc. or the information about the location of the object is going to be stored, whereas in attribute table the properties of the polygon is going to be stored. So geometric table contains vertex coordinates and the other parametric which specify geometric of polygon, means location of polygon. Attribute tables store other informations like color, transparency and many more. Sorry. A convenient way to represent geometric table are in three different, that is, we can represent for vertex table separately, edge table separately, and polygon table separately. So these are three different ways in which a polygon can be represented easily. So suppose this is a polygon. It contains two faces. One is V1, V2, V3. Second one is V1, V5, V4 and V3. So this is one face, this is another face. The vertices of V1 are X1, Y1, Z1, as this is the object of three-dimensional. This is one edge of this plane, this is second edge of the same plane, and this is the third edge of this plane. And this edge is common in both the planes, that is E3, E4, E5 and E6. So these are two faces, surfaces, that is one is S1 and one is S2. So we can represent the vertices in the table that as there are five vertices V1, V2, V3, V4 and V5, and the values or the coordinates of V1 is X1, Y1, Z1. So this is X1, Y1, Z1. The coordinate of Y2 in same the representation, that is X2, Y2, Z2. For V3, X3, Y3, Z3. For V4, it is X4, Y4, and Z4. And for the last coordinate, that is V5, these are X5, Y5, and Z5. So this is a vertex table where we can store all the informations of the vertex. This is a edge table. In edge table, we have to store all the edges and have to keep the record different number of edges, as each and every edge has two endpoints, means two vertices. Or in simple word, we can say that if we join two vertices, then the line that joins these two vertices is called edge. So over here in both the planes, you can see that E1 is the one edge, whereas E2, E3, E4, E5, and E6. These are six different edges. So this is written by E1, that is edge 1, where the vertices of E1 is V1 and V2. These are the vertices. By joining these two vertices, they formed a edge E1. Same, this is E2 is made by the joining of vertex V2 and V3. This is E3, vertex V3 and V1 E4 vertex V3 and V4 E4. This is E4 vertex V3 and V4. This is E5, the collection of vertices V4 and V5 you can see over here, and the last edge, that is E6, is the collection of V1 and V5 edges. In edge table, we can interchange these two vertices also. Means we can write V2 in place of V1 and V1 in place of V2, because this is a non-directed graph. So third one is polygon surface table, where it represents that how many different phases this polygon has, and as the polygon is made up of by the joining of different edges, so we have to store the information of edges those are connected to form a surface. So here surface S1 made by joining the edge E1, E2 and E3. So S1 is the surface that is made by the edges E1, E2 and E3. Whereas surface 2 is made by the edges E3, E4, E5 and E6. So you can see over here that surface S2 is made by the joining of or by the edges E3, E4, E5 and E6. So this is the representations of a polygon in the form of table, where we have to represent vertices in separate table, edge in a separate table, and the surface of the polygon is in the different table. Means there are three tables to store the values. So there is one another way if we want to store the edges. Edge over here, edge is going to represent E1 by V1 and V2. Here I wrote the as E2 by V2 and V3. In the next slide, you will see that two table representation is efficient, as it will store common as multiplication many times. As you will see over here, when we are going to represent an edge, then in that case, same vertices is coming many times. This is V1, this is again V1, this is again V1, this is V2 over here, this is V2 over here. So there is a lot of repetition of the vertices when we are making a edge table for a polygon, and this V1 is coming three times because this vertices has only three edges. If there will be 10 edges or more than 10 edges, then it will repeat 10 times. So this is the problem that as in a edge representation, a vertex is going to repeat or going to save many times. So instead of two table representation, we represent this in this way. So this is sometimes it may be possible that error may occur during input. For dealing with that, we add extra information into the table. For example, as table with information of the surface in which particular edge is represent. As over here, you can see that this E3 is in both the surface, that is S1 and S2. So sometimes it is difficult to analyze that S3 is concerned with S1 or S2. So by this way, we can represent or we can write the table as table that represents the surface also. As you can see over here, E3 E3 is going to represent V3 V1 for surface S1 and V3 V1 for surface S2. So this is the way to represent the polygon in using the tables. But again, as I told you, this is the main problem to represent a polygon in terms of tables, as we have to store and repeat many information repeatedly. In the vertices also, you can see over here that when we are going to store vertices, then vertices are going to be repeat. In the case of vertex table, when we are going to store the vertex table, then in that only and only the value of vertex coordinate, that is x1, y1 and z1, is going to represent only once, not more than one. So this is, we cannot minimize more than this. So this is the representation or minimum representation of the vertex table. So this was about the polygon tables, that how we can represent it using polygon tables. Now in the next class we will discuss about the plane equations. Now thank you. Thanks a lot.